Welcome everyone. I'm going to be showing you my filler game recreation. The way this game is played is you have a big square of 8 by 8 littler squares, and they are made up of random colors. And there's a color bank of 6. The only caveat is that no color can be touching its same color on any side. It can by diagonal, but it cannot have the same color on one side to start. Player 1 starts up here. This is the first square that they own, if you will. Player 2 starts here, and this is the first color they have. The goal of the game is to get the most squares, and you can see the score here. So as player 1, you can start by picking a color. Ideally, the best one you want to do is going to be yellow or black, because you're trying to the way you gain a square, one or many, is you have an adjacent square to yours. So diagonals, again, don't count, but any of these colors I can add to my score, or add to player 1's score, by changing to that color. So we'll start with black. So now both of these are my squares. Now it goes to blue's turn, or to player 2's turn, and they're currently blue, but I can pick any color except black. So any color that is smaller, meaning the other player's color, I can't choose. On this first and only this first turn, I guess I could actually pick blue and stay there, and then it would make it that the next time I could not pick that again, and player 1 could not pick that on their next turn. So for this sake, we'll pick red. Now both of these, all three of these are my color, or are my squares. So now it's back to player 1, as you can see up here. So player 1 cannot pick black or pick red at this point. So we'll have them pick yellow. Now they have these 3. So I can go over here, and either I could pick purple or I could pick black, because either by this square, I would get both. I'd get this one, and this one will definitely get this one. Now it's back to player 1's turn. It's really kind of just dealer's choice. We'll go with purple. And then back down to player 2. So we're going to go with blue. And back to player 1. We'll go with black. Player 2. We'll say green. Player 1. We'll go with blue. Player 2. Let's go with yellow. Player 1, let's go with green. Player 2. Now this is an interesting part of strategy. We're not really talking about much strategy here, but one thing you can look at is I could pick purple. However, I already kind of own this one. There's no way that the other player could get it. So it would actually be better to just keep being offensive and trying to grab more squares. So I'm going to go with red. And then I'll have player 1 pick purple. I'll go ahead, and I can't pick purple, so I can't grab that one. So let's go with black. Now, it's kind of a good move, because black would have been a good one for player 1 as well. They can't pick it until next turn. So let's go with yellow. Player 2 can now pick, let's go with purple. Player 1, we'll go with red. Player 2, I'm actually going to go with green for down here. Player 1 can pick black now. Player 2, we'll say yellow. Player 1, now we've got these kind of 2 corners here. I can try to go and attack, trying to get one of those. So let's go with blue up here. We're going to have player 2 go with red. Player 1, we'll say green. Player 2 with purple. Player 1, we'll say red. That's the strategic. So this one's kind of done and over. So the best they can do is go down this path. So player 2, I could drag green, but it's actually not going to give me anything better, so might as well go with black. Now they'll go with green. Player 2's turn, so be blue. And in this case, player 2 had more, so player 2 won. Now to go on to what the code looks like. So we'll start here on the HTML. Very much like the other HTML code files that I have. We have our introduction, all the header metadata information. We have our card, which is just that pop-up of that everything's put on. Then we have our table, which holds our game board. And then to the right of that, we have all of our player options wrapper. So the player ID, which player is up and making decisions, the different boxes to pick the color, and then the scores, which also includes who won at the end. Let's go to the CSS. So for my different color squares, I have these classes for each of the colors. I have them labeled by their actual numerical number or numerical identification. And so 0 is black, 1 is green, 2 is purple, 3 is red, 4 is blue, 5 is yellow. Any of my table data, so like your cell type things, which is the squares, I've given just a square width and height. The table itself, I just have centered. The card is flex, so it just makes it so that the divs are right next to each other. Player options wrapper, I just give it some margin on the sides. The ID of options, I have flex, so that's where I have player 1 score and player 2 score. The outer wrapper is that, so it allows it to be side by side with a margin. The options square, so this is on the right side where you actually get to click, and those are 50 by 50 with a margin as well. Separate them out a little bit. I also have a class for when they are disabled, so when they make them a little bit smaller, I shrink them and give them a little bit more margin. The score wrapper, I just make that flex. Player score, have a little margin around that. And the in-game message, when that pops up, I increase the size of the text and give it a little bit of margin. So now looking at the JavaScript. Start out with some variables. So we have our game board. We have our player 1 array and player 2 array. If is it player 1's turn, we start out as true, and then we toggle that, so if it's false, then it's obviously player 2's turn. Player 1's color code, so what color are they currently, and player 2's current color code. So we start out with -1, because then it can never be that again. So for our setup function, we have a set width and height. So when I call it down here, I have it set to 8 by 8, but that can be changed if you ever want to have it be bigger or smaller. So I'm going to cycle through, and as long as, so I'm going to make a 2D array. So to create a row, I'm going to create however many I've set in here, so the height. So in this case, it'd be 8. So I'm going to cycle through, create a new row for each of the different rows in the 2D array. Then I'm going to have a nested for loop, and I'm going to handle the width. So I'm actually fill that row array. I'm going to select a random number. It's going to give me a decimal, so I just multiply it by 100 and modulo it by 6 because there's only 6 options. If k So if we're in the first row, then all I'm looking at is the box before it. So the square before, and make sure it's not the same color that has been selected. If so, then while it's the same as the one before, the same number code, then I'm going to find another random number. So if that makes sense, again, we have a square. So we have our square. And as it's going to pick this next color, so this one's fine, there's nothing before it. This one, though, has to make sure that it's not, that it wasn't purple right here in order for it to set that color. Let's say it picked black. Well, it can't be there, so it's going to have to, it randomly picks another color until it's not whatever the color was before it. That is what this line is doing. If it's not that first line, then it's going to look at what is before it. So what's on top of it, and what is right behind it. So we switch back here. So for any of these other rows, it's going to check above and behind it. So in this case, it would just be looking ahead, above. This one's going to look to the left and to the top. We don't need to check the bottom because those haven't been filled in yet, and as we keep going, it's going to keep checking that. And so that's how we get it filled in correctly. We then push that number to the row. We fill up that row, and then when that row is done, we push that row to the actual game board. Then we add a square to a player. So we're going to give it the array, which is player1 array. And we're going to give it an index. So for player1, it's in the first row, which would be 0. And then it's going to be the width minus 1. So this is very dynamic. We can have whatever height. Nothing is hard-coded here. So it's going to be the far right corner. And then inversely, we have add square to player. We're going to give the player2 array. And it's going to be the height minus 1. So it'll go all the way to the bottom. But it'll be in the 0 column. Then we're going to call display game board, display player scores, display options. And this we also have dynamic, so we only have 6 options, which actually I guess that is hard-coded here, so you could pull that out. I just chose to leave it here. And display player ID. So for display game board, which will be the next thing that gets called on setup, we have a variable that's empty, a string basically. And we're going to cycle through the game board length. And we're going to add the tr, which is table row. And again, that whole nested loop so that we can fill in the TD elements, table data, and give it the class that's appropriate for it. And we're going to convert the number to string. So we're just passing in whatever that index in the game board is. It'll take that that number, numeric value, and turn it into a string for our class. We tack on the end of the table row and add that whole thing to our game board inner HTML. For display players scores, we have a player 1 score and player 2 score, and they're virtually the same thing. We have a div with class player score, player 1 score, and we just give the length of that array for player 1 and for player 2. We then put them together so we can have a wrapper, so they're going to be side by side. And we have the winner message. So we're going to set it to be empty if player 1 array length plus player 2 array length equals 64, then we're going to, then we know that the game is over. If it's not, if they don't both equal 64, then it's over. Again, that part's not quite dynamic, so this would be a good place to make it more dynamic by multiplying the height and the width of the game board. If player 1 array length is not equal to player 2, then we know that there's actually just one winner. And then we can do an inline if statement to determine if it's player 1 or player 2 that has won. So if player 1 is greater, we'll go with 1. If player 2, if not, else it's going to be player 2 that won. If they are equal, then we know that the player 1 and player 2 have tied. We add those together, player scores and the winning message, and add that to player scores. Display player ID. This happens every time that there's a selection made, and we just change who the player 1's turn is. We just display that. Or we display which player it is based off of which player, the boolean of player 1's turn. If it's true, it's player 1, obviously, and if it's false, it's player 2. For display options, we pass in a number or number of colors, and we cycle through those and display them. To convert to num to string, we pass in a number, we do a switch statement, 0 through 5, we pass out 0, 1, 2, 3, 4, 5 spelled out. Add square to player. So this is where we pass in the specific player array and the index row and the index column. We take that player's array and we push that index row and index column as its own array. So we can see that we're going to add that. So it's going to be an array of arrays, but it's just going to be an array of 2D of length 2 arrays. We're going to change player's color, and so we're going to pass in the color number. It knows which player it is because of that true false. So if we're going to first check to see if the options side, so that's going to be on the right hand side over here. We're going to check to see if that has the class options squared disabled. And so if it does not contain that class, then we're going to go into the rest of it. Otherwise, we're not going to do anything. If it is player 1's turn, then we will disable player option. So we're going to add this class to that color option. Then we're going to go through player 1 array, and for each of the different for each element in that array, we're going to get the game board. So we're going to go to the game board and pass in element, the row and the column index, because again, it's going to be an array of arrays, and the arrays inside are only going to be of length 2, because it's just going to be index 0 is going to be the row index, index 1 is going to be the column index. And then we're going to set that to be the color number that is now selected. So for all the ones that we already own, we're going to change their color to be whatever we just selected. Then we're going to select player 1 color code to be whatever that color is we just selected. So let's say we turned it to black. It went through and knew that we owned that one and changed it to black. Now here we have purple. So if I turn it to green, then it's just going to change that, the one that's in there. Now I can come here and I can say, okay, well, I want to go to blue. So I change that to blue because the other two weren't owned. Now if I change this to yellow, say the same, that now both of those are owned. But if I come here again, like we were showing before, if I turn black, well, those 3 were now owned by me or by player 1, and so now all 3 of those were changed. And then if it's so the same thing happens just for player 2. Then we're going to add new colors to player. Display the game board again. Display player scores. We're going to toggle the player 1 turn, so whoever's turn it was, we're going to negate it, so it'll flip it back to the other way, to the other person. And then we'll display player ID. To disable a player option, we pass in the color code, the current color code, and then the next one, and then what the next color is going to be, the newly selected one. If the current color code does not equal -1, so like normal gameplay, then we're going to remove it. If it does, then we know that isn't there on any of them, and so we're going to add the color list or the options square disabled to whatever one was selected. So no matter what, we add it, but if it's the first time, then we have to go and remove it. Sorry, that's the other way around. If it's not the first time, we have to go and remove it. If it's the first time, we just bypass this section. So add new colors to player. So we're going to have a temp new colors array. These are going to be, so someone selects that new color that should match to surrounding squares, and now we're going to go and find them. Only the new ones, not the ones that already are owned. So we're going to have an empty array. If it's player 1's turn, then we're going to go to player 1 array, and for each element in there, we're going to cycle through, and we're going to add to it all of the new squares that are now that have been attached to us to our color block. So we're going to call a function add array to array, and we're going to pass in the temp colors or new colors array, and this other function called get surrounding new colors. We're going to pass in the element, so which square we're talking about in the stuff that we already own, and the new color code for that player. And these are basically identical, just for the different players. This is going to return us all the new colors. Then we're going to add that array to whatever is existing in this array. That will get added to player 1 array. And this add array to array is just going to make sure that there's no duplicates in there, because that will exponentially grow that array list. So to first start, let's talk about get surrounding new colors. So we're going to pass in the current color index, which again is that array of size 2, and the player color code. We're going to have the result array. We're going to set that to empty. Now I kept this commented code, and we're going to talk about this first because this is how I originally did it. I realized it was not the smartest way later, but I wanted to keep it because it is still a correct way. It's just not the most efficient. I went to each of the corners first. So in this case, I went here, 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 and here, because I knew that there were only 2 options there. And so I check for the top left, the bottom, and the right, the top right, the left, and the bottom, and so on and so forth. Then I also chose each of the sides. So if we cut out the corners, then we have this side of these 6, this side, and this side. And all of those only have 3. They've got each side and in the top. But they don't have this one, the bottom doesn't have a bottom, the right side doesn't have another one on the right, the top doesn't have another one on the top, and the left doesn't have another one on the left. So they're all going to be a little different. And then for everything else, we've got the center square here. All of these have all 4 sides that need to be checked. So what that means is when I did it here, it's going to check, okay, did this one or this one get added? And then for this square, did this one, or this one get added? And then for this square, did this one, or this one get added? And then for this one, it'd be this one, or this one. and then we're going to remove any of those duplicates because there's some overlapping there. What I found out though, or what I realized, so that's where that's a lot of complication. What I realized though is we can have it run through each of 4 if statements. So if it's everything but the bottom row, then we know, so everything but this row, we know has something below it. Everything but the top row, we know has something above it. Everything but the right row, we know has something to the right of it. And everything but the left row, we know has something to the left of it. So again, like this one, it's in that most left column, except for being the most left, we know it has something to the left. So that's what I did here. So everything but the bottom row, we can safely know that we can get something more on that bottom. And if that equals the same color code that we're passing in, then we can add that to the result array. Everything but the top row, we know it has something below it. Everything on the right row, everything but the right row, we know has something to the right of it, and everything but the left row, the far most left row, has something to the left of it. So that's all of this code right here that's been commented out was replaced by these lines of code right here. So we get that result array and we return it. Then we have this add array to array. What I realized was when you have 2 arrays and you want to compare them, at least from what I was researching, they are not equal. Even if they look equal, so it's an array of 1, 2 does not equal array 1, 2. So I had to create this array that will actually, or this function that will actually do that. So we give us, so this array and this array, we give it the temp array, which is going to be array 1. We're going to cycle through the length of array 2, and temp array, we're going to add element to it, and we're going to pass in array 1 and array 2 in the first index, or in the index that we're going through. And then add element to array, we'll take in that first array and the element that I'm giving it. In this case, element is just this specific index. So let's be more specific. So we're going to bump up here. In this case, we have this empty array. And then we have all of the results, which we know have duplicates in it. And these are going to be nested arrays. So again, the empty one goes here. So now we have a temp array that's empty, and this one has all of the new squares in it. Now we're going to cycle through that second array, and we want to make sure that only what we add to our temp array are non-duplicates of what is already in here. So we have the full array here, and we're going to pass in just one element of that, which is going to be one of those 2 length 2 arrays. In that here, that passes in. The array again is our empty one initially, or at least we know that has no duplicates in it. So for add element to array, we don't need to make sure that the array is greater than 0. So we're going to get rid of that. So in this, we have an array. We want to add an element to it. We cycle through the length of the array, and we make sure that we go through element 0 and element 1 of the internal arrays. So we're going to cycle through each of its internal arrays, and we want to check both of those and make sure that it does not equal the element that we're trying to add to its 0 and 1. If they equal, then we just want to return the current array. If it cycles all the way through, then we make this temp array, which equals the array. We add the element to it, and then we return the temp array. We probably don't need to, but I wanted to make this very verbose, clear and understanding what we're actually doing. We're adding that to the array and sending it and returning it back. So for each of the elements in the new array, we're going to cycle through that and call this every time to add to it. This will ensure that we don't have an ever-expanding array, which is going to really impact optimization. If you have a much bigger square, let's say you do 100 by 100, that'd probably be a very long game, but you could really start seeing how the optimization will get much slower. So this probably is not the most ideal way of searching. It's going to be for this reason right here. That will probably be pretty big. I've yet to try it, so it'd be really cool to see how big it gets until you can really start seeing the optimization of it taking a long time to change those colors and process someone's turn of choosing a color. But this is what's going to ensure that we only add to the player's array non-duplicates, which is again why it gets called twice. So we have this add array to array here, but then we also have it when we add to the player one array. We want to make sure that none of these are actually duplicates in here as well. So if they're already in here, then they won't get added to it, and again, ever expanding. We have a reset function, which just resets everything. Our filler load, which gets called on our add event listener of load. That is filler. There's definitely some places for some improvement. It'd be really cool to see how you guys want to change it and make it optimized even better. Let me know, and see you guys next time. Bye.